Hi students, this video is going to explain your third programming assignment. The name of the program is, actually there's two options for this program, so that might change the name. But the topic is the number of A's in a string that you feed through your resulting machine should equal the mod value of the number of A's when you mod by, and that's the optional part. Let's say 4. If you take the number of A's in the string and you mod it by 4, that should equal the number of B's when you mod that by 4. So let's, over here on this side over here, let's write some good strings so you sort of see what I'm talking about. So I want to be losing my mouse right and left today. All right, let's see. Okay, so if I need to mod by 4, then a string that is, let's say this, A, 4 A's in a row. If I count up the number of A's and I mod that by 4, that gives me 0, because 4 is a multiple of 4. So the number of B's is going to have to also be a multiple of 4. So 0 B's is a multiple of 4. That means that string is good. But so would a string that has 4 A's and 4 B's. Like this. 1, 2, 3, 4 A's and 1, 2, 3, 4 B's. That would be a good string in a mod 4 machine. So would the string that has no A's, 0 is a multiple of 4, and 8 B's. So this string would be a good string in a mod 4 machine. Now, you don't always have to have a multiple of the mod value 4. For example, if you have, let's say, 3 A's in a string, well, 3 modded by 4 is 3. That means that the number of B's has to also be 3 more than a mod of 4. So 3 B's would work, like 1 there and 2 there. That would be a good string, but so would the string that has 7 B's, because 7 mod 4 is also 3. So you have 1, 2, 3, 4, 5, 6, 7 B's and 3 A's. 3 mod 4 is equal to 7 mod 4. So that means this is a good string. The machine that you're supposed to build, if you decide to build a mod 4 machine, should make sure that the number of A's modded by 4 is equal to the number of B's modded by 4. If you had 6 A's, that means, so 6 A's, 6 mod 4 is 2. Therefore, your number of B's, when you mod that by 4, that should be 2. So what numbers, when you mod by 4, will give you 2? 2, 6, 10. There will be a gap of 4 in between all these numbers. 14. All these numbers, when you mod them by 4, will produce a 2 for the mod value. So I hope that makes sense. What you're trying to do is make a machine that will accept any string where the number of A's modded by 4 is the same as the number of B's modded by 4. You do not have to have the same number of A's as B's. You just have to make sure that when you take the A count and you mod that by 4, you get the same number, 0, 1, 2, or 3, as you get when you take the number of B's and you mod that by 4. All right, but now to draw that machine from nothing is kind of tough. So we're going to start with, let me make a new page. We are going to start with a simpler example for mod 3. We're going to make a mod 3 machine. And we're going to do it, we're going to do it one step at a time. Now, what are the different mod values when you mod by 3? The different mod values are always, they always start at 0, and they go up to 1 less than the number you're modding by. So 0, 1, that's supposed to be a 1. 0, 1, or 2 are your different mod values when you're modding by 3. Now, what states are we going to need if we're keeping track of these mod values for both A and for B? We're going to need a 0, 1, 2 for our A count, and we're going to need a 0, 1, 2 for our B count, because we're taking each of those counts and modding by 3. So we need these states. I'll use a shorthand. This is the mod value for A, and this is the mod value for B. That's my A mod value, and this is my B mod value. So I need 0, 0, 0, 1, 0, 2. Then I need 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, and 2, 2. Those are all the possible combinations of a mod 3 value for the A count and a mod 3 value for the B count. And the states that are going to be accept states are the ones where the A count modded by 3 is equal to the B count modded by 3. So that's going to be an accept state, and this is going to be an accept state, and this is going to be an accept state. All right. We have some dog issues here. Bela, knock it off. Growling at a cat. All right. Now, what's our start state? Where you've seen 0 A's and 0 B's. If you take 0 and mod by 3, you get 0. So our start state is going to be this 0, 0 state. And we've already said that that's one of our accept states. Okay. This goes with A's, remember, and this goes with B's. If you are in this state where you've seen a multiple of 3 A's and a multiple of 3 B's, because that's what this means, and you get an A, then your mod value for the A count goes to 1. You have 1 more than a multiple of 3 A's. So if I get an A from here, I'm going to go to the state 1, 0. If I get a B from here, I'm going to go to 0, 1. Remember, these are mod values. The number of A's modded by 3 is still 0. The number of B's, however, because I got 1 here, I had a multiple of 3, now I have 1 more than a multiple of 3 B's. All right, so this state's finished. I have an A and a B. We got to do that for every state. And we have a total of 9 different states, so this machine's going to get kind of crowded here on my page. So if I'm in 1, 0 and I get an A, where do I go? I would go to 2, 0. Because the A mod value changes, goes up by 1. The B doesn't change. If I get a B from here, I need to go to 1, 1. If I get an A from 0, 1, I'll go to 1, 1. If I get a B, I will go to 0, 2. Oh, now remember this state 1, 1, this is one of our accept states. Okay, now if I am in state 2, 0 and I get an A, what happens to that 2? I hope you just said to yourself, why, it goes back to 0, because that's exactly what happens. It goes back to 0. We're going to have lots of cycles of size 3 in this machine. If we are in state 1, 1 and we see an A, then we need a state 2, 1, and we don't have that yet. State 2, 1 on A is where we go. In state 1, 2 is where we go on B. We don't have that yet. 1, 2. Okay, so that state's finished. Now state, let's do this one down here, 0, 2. If we're in state 0, 2, and we get an A, that'll go to 1. So we need a state 1, 2. Here it is. On A, we'll go to 1, 2. Where will we go on B? 0, 0. So back around to there on a B. If we are in state 2, 1, oh, I have some scrolly room here, yay. Okay, if we're in state 2, 1 and we get an A, then this is going to go to 0. So we need 0, 1. That's down here. Okay, that's kind of ugly, but so be it. There's an A. And look, here's another cycle on the A's. If we're here and we get a B, then we need to go to 2, 2. That's another except state, 2, 2. All right, now if we, oh, that state's finished, yeah. So this state's finished. This state is not finished. 2, 0. I have an A, but where do I go on B? Oh, on B from state 2, 0, I need to go to state 2, 1. 2, 1, yes. Now, that state has AB, this has AB, this has AB. This one doesn't have anything. So from 1, 2 on A, I go to 2, 2. From 1, 2 on B, I go to 1, 0. Okay. On B. So there's a little cycle of size 3. We got cycles of size 3 all over the place. Now if we're in 2, 2 and we get an A, we need to go to 0, 2. That's down here, another cycle of size 3. And if we are in 2, 2 and we get a B, then we need to go to 2, 0. That's up here. So now, I hope you see what I have just done. But this is not the machine you're going to program. This is a Mod 3 machine, and it's not even the finished Mod 3 machine because I want you to minimize this machine. That machine is full of redundancies. If you minimize that machine, and I would suggest maybe you rename states, although those names aren't too bad. But if you minimize, you will find out that you only need 3 states, not 9. After all, just 3. Look at this paragraph right over here. Once you see the pattern for a minimized Mod 3 machine, you can probably predict the machine that accepts strings where you're doing a Mod 4 instead of a Mod 3. Believe me, you'll be able to do that. Just use the same pattern. It's remarkable. This is the coolest machine ever. When I first discovered that these mod machines minimized the way they did, I was blown away. I was like, you gotta be kidding me. That works? But it does. So do it. Minimize this machine for practice, and you'll just be so startled if you were like me. And if you are not, too bad. But anyway, so once you see the pattern for the Mod 3 machine, the Mod 4 is just going to be almost the same with one extra state. It only needs 4 states. So once you've got the Mod 4 machine, you will put it into a table. It will have, you got 4 states, so you will have 1, 2, 3, 4 rows to your table. And you will have, does this say we need to take, to handle, hold on a minute. Need my other mouse. Do I have to handle other odd characters other than A, B coming into my program, or can I just pretend that they won't come in? What does this say? It doesn't say. All right, so I'm making a decision. Oh, wait. Oh, it does say, unfortunately. Be sure that any character that is not an A or a B causes the string to be rejected. Okay, so that answered that. Back over here, That means that I need in my table a column for A, a column for B, and a column for other. And I also need an extra state, a trap state. So if I end up with states 0, 1, 2, 3, and 4, with 4 being the trap state, then I will stay in 4 no matter what I get, and all of these other rows would take me to 4. This is the part that is the most interesting right there. The rest of it just comes because we're turning it into a program that can accept input from a fallible human who might give us something other than A or B. But this is really cool. So you do this mod 4 machine, and that's worth 25 points. Now, for an extra 5 points, you can do a mod by anything machine because of the pattern. See that neat little pattern that you will see when you minimize the mod 3 and that you will use when you build your mod 4, that holds for any mod value. So for the 5 points of extra credit, you can have your program ask the user for the mod value that they want to use, and then you can build your table on the fly inside your machine. Write code to build this table. If they want a mod 7 machine, you will need 8 states because of the trap. If they want a mod 10 machine, you would need 11 states. And then you'll see the pattern that results from this operation, minimizing the mod 3 and then using that same pattern in a 4. You can, because there's such a clear-cut pattern, you can do any mod value, just incorporating the use of that pattern into the table that you build on the fly. And if you do that, that's worth an extra 5 points, which will help pad out the number of pre-final points that you get. Okay, write to me in email. I'll try to be answering emails while I'm gone. So write to me if this is not clear, or write to Joey. Joey, I will tell him that you might be writing to him. You can write to me, but if I'm not immediately responsive, there's a time difference, and there's also me not being in a place where I have internet difference. You might want to try Joey too. Write to both of us at the same time. Just put both of our names on the email, and then you will get the fastest possible answer. And Joey's email is Nuhfer, Nuhferj something. What is it? Hold on. Oh, there it was right there. I had been writing to him. NuhferJC. NuhferJC at appstate.edu will get you a nice answer to help clarify what's going on with this program number 3. When you're finished with it, you will submit it the same way you've been submitting the others, like this. Submit DAP prog3 and whatever you called your Java file. Okay, thank you.